Good day, grade 10. This is day 42, lesson 2 of Analytical Geometry. It's the 2nd of June. And today we're going to start with the first formula that we are going to learn, and that is the distance formula, or the formula to calculate the length of a line segment between 2 points A and B. Okay, so to calculate the length of a line segment, we are going to use this formula, the one that's highlighted. AB is equal to the square root of xb minus xa squared plus yb minus ya squared. Or, if I can just take the square root over, it becomes a squared. I can also have the formula on the left, ab squared, that formula. Okay, so this formula comes from Pythagoras. You can read more about that in your textbook if you want to. And let me just check the page for you. You can read more about that on page 188 if you want to. You can see where it comes from. But if you don't want to know where the formula comes from, it's just important that you study this formula. You just have to know it by heart. Okay. Now, we're going to use this formula to calculate the distance between 2 points. Let's start with an example. We have the example. Oh goodness, just let me go back a little bit. We have the coordinates, and the question says prove that triangle ABC is an isosceles triangle. Okay, so I have to prove that it's an isosceles triangle. Isosceles have two sides of the triangle equal. So I'm going to try to work out all the lengths of the sides of the triangle. So all the lengths of the line segments. So I'm going to use the distance formula. So let's first start with AB. The formula to calculate AB is xb minus xa squared plus yb minus ya squared. And the square root of that will give me AB. Now, let's go see where do I find xb, xa, those things. So, first I have a's coordinate. That 2 will be the x coordinate of A, and the 3 will be the y coordinate of A. So that's what those stand for. And B will be the x coordinate of B, the y coordinate of B. So then I go put them into the formula. XB was 7, so it is 7 minus XA. Oh, guys, I'm sorry, I'm working with Y. Okay, XB was 5 minus XA, which is 2. So it's going to be 5 minus 2 squared plus YB is 7 minus 3 squared. 5 minus 2 is 3 squared, and 7 minus 3 is 4 squared. 3 squared is 9 plus 16. The square root of that is 25. Square root is 5 units. I always put units there because they don't give me centimeters or meters or anything like that, so I just put units. Okay, so now I have the length of AB, which is 5. Now I'm going to work out BC. BC is xc minus xb squared plus yc minus yb squared. Okay, so I know what xb and yb is, but what is xc? xc is negative 2 and yc is 6. So I go substitute it in there. Negative 2 minus 5 squared plus 6 minus 7 squared. And the square root of that. So that will be the square root of negative 2 minus 5 is negative 7 squared plus 6 minus 7, which is negative 1 squared. Now, negative 7 squared is negative 7 times negative 7, which gives me positive 49, plus negative 1 squared, which is positive 1. 49 plus 1 is 50. So BC is the square root of 50 units. Okay, you can go work out the square root of 50 and we'll give you 3 comma something, but that's not necessary. You can leave it just like that, square root 50. Okay, so far we don't have any equal sides. So far we don't have an isosceles triangle. Let's see if the third side is equal to any of those. So let's work it out. AC is equal to the square root of xc minus xa squared plus yc minus ya squared. Okay, that gives me negative 2 minus 2 squared plus 6 minus 3 squared. And that is negative 4 squared plus 3 squared, which is 16 plus 9. The square root of 25 is 5 units. Aha! Now I can clearly see that AB and AC both give me the answer of 5 units. So that says that triangle ABC is isosceles because AB is equal to AC. For the second example, they ask that we take the same triangle and prove that triangle ABC is a right angle triangle or a right triangle. Okay, so that is the sketch. Let's remember AB was 5 units, AC was 5 units, and BC was square root 50 units. So let's write that down. BC is square root 50 units. So D, do you remember Pythagoras? Pythagoras says that it only works in a right angle triangle. So if I can take these lengths and do Pythagoras, AB squared plus AC squared, and that gives me 25 plus 25 is 50. And I take the other side, BC squared is the square root of 50 squared. Remember, a square root and squared cancel one another out, so the answer is just 50. Aha! I can now clearly see that these give me the same answer, which means Pythagoras works. When Pythagoras works, I know it's a right angle triangle. So that says that triangle ABC is a right triangle because BC squared is equal to AB squared plus AC squared, and this is the converse of Pythagoras. Converse of Pythagoras. Okay, so that's the first example. Okay, then I want to explain something. If they ask me to determine a coordinate if the distance is given, okay, say for instance, they give me CD, which is the square root of 34 units, and they give me the coordinate of C is negative 5, 6, and the coordinate of D is negative 2y. They give me the sketch like this, CD, and C is negative 5, 6, and D is negative 2y. So that y is unknown. It's a variable, so I need to determine that. Determine y. Okay, let's remember they said that the distance is square root 34 between them. Okay. Ooh, that looks like 84. Let me just make that clearer. 34, square root of 34. Alright, now I have to determine y. So let's write down the formula for determining CD. The distance formula is the square root of xd minus xc squared. Please study this formula, you need to know it. Plus yd minus yc squared. Okay. Now I'm going to put in what I have. xd, the x value of d, is negative 2. Minus the x value of c is negative 5. Minus negative 5 squared. Plus the y value of d is y. Minus the y value of c is 6 squared. Now I have minus 2 minus negative 5. That is minus 2 plus 5, which is 3. Okay, so let's just put in what CD was. CD was square root 34. Now, I have on both sides a square root. So I can square both sides to get rid of the square root. So if I square both sides, I'm rid of the square root and I just have 34 is equal to 3 squared plus, now I have y minus 6 squared. That is actually a FOIL rule. So what I'm thinking at this stage, I'm thinking that I have y minus 6 times y minus 6. And now I do the FOIL rule. So how do I do that again? It is y squared plus minus 12y plus 36. Okay, now I see that I have a quadratic equation. So the rule for quadratic equations is to bring everything to the right hand side so that I have 0 on the left hand side. So I have 0 is equal to y squared minus 12y plus 36 plus 9, because that 3 squared is 9, minus the 34, which comes over to the right hand side. Now I have 0 is equal to y squared minus 12y plus 11. If I factorize that, I get y minus 1, y minus 11. I set them both equal to 0 separately, so I get y is equal to 1 or y is equal to 11. Okay, now I go back to my sketch and I go check. Where does D lie? Does D lie closer to y is equal to 11 or closer to y is equal to 1? Remember, 1 would be around here and 11 would be way up there somewhere. So it's definitely 1. The 11 would be not applicable and y is equal to 1 is the answer. So what I have then is that the coordinates of D would be negative 2 and 1. Okay, that's the example. Now I want you to do exercise 1 on page 190, number B, C, D, and E. This is the exercise. It's also available in your notes. So you go do those numbers now. And then when you are ready, you come and press play again and we will mark the exercise together. Okay, welcome back at exercise 1. This is your memo for exercise 1 on day 42 on the 2nd of June. Now you have done the exercise and we are going to mark it. The first question says that we have two triangles and we have to show that it is an isosceles triangle. Okay, so just ignore that this sketch is in Afrikaans. It doesn't matter. We are just looking at the sketch part. Okay, so now to show that it's isosceles, I'm going to try to work out these two sides, AB and BC. Okay, so the formula to work out AB is AB squared is equal to XB minus XA plus XB minus XA. So I work that out by substituting in XB, the X value of B is negative 2 and the X value of A is 2. Alright, and then I'm substitute in 3 minus 6 and I get negative 4 squared plus negative 3 squared, which is 16 plus 9, and that is 25. To get rid of the squared, I get the square root, and 25 square root is 5 units. So 5 units for AB. Now I have to work out BC. BC squared is 5 minus negative 2 squared plus 7 minus 3 squared. And that gives me 9 plus 16, which is 25. To get rid of the squared, I get the square root, and I get BC is 5 units. So that tells me that AB is equal to BC, so ABC is an isosceles triangle. Now for the next one, they ask me to determine that it's a right angle triangle. So to determine if it's a right angle triangle or a right triangle, I can use the converse of Pythagoras. So first, I now know that those two sides, AB and BC, is 5. Then I have to find AC. Okay, AC squared is 5 minus 2 squared plus 7 minus 6 squared, which gives me 50. To get rid of the squared, I get the square root. Oh, I don't need to find the square root right now. I just need to find AC squared. Then I get AB squared plus BC squared is 25 plus 25, which is also 50. And because those are equal, AB squared plus BC squared is equal to AC squared, I know that triangle ABC is a right triangle because of the converse of Pythagoras. Okay. Then number C. C says, if I have a point C and I have a point A and a point B, I have to show that A is the same distance from C as B. So if I can work out AC and work out BC and the answers are equal, then I have shown that. So let's work out AC. AC squared is 2 minus 3 squared plus 3 minus 6 squared. You have to have the notes or the textbook open to see where these numbers come from. And then AC squared is negative 1 squared plus negative 3 squared, which is 10. To get AC, I get rid of the squared by getting the square root. So AC is square root 10 units. Then BC I do in the same way. And I also get square root 10 units. So that means that A and B are the same distance from point C. Now, number D in your memo is totally wrong. That's not what you were supposed to do. So there's a correction page that your teacher sent to you, and this is the correction page. So here's what you do. They say C and D are square root 53 units apart. The coordinates of C is 1, negative 2, and the coordinates of D is x, 5, and we need to find x. So as in the example, I'm going to write down the formula for CD, the distance formula. So it's xd minus xc squared plus yd minus yc squared. Then I find the x value of D is x, the x value of C is 1, so it's x minus 1 squared. The y value of D is 5 minus negative 2 squared. Okay, x minus 1 squared is the FOIL rule. So do the FOIL rule and you get x squared minus 2x plus 1. 5 minus negative 2 is 7, squared is 49. Now because I have squared, I have a quadratic equation, so I take everything over to the one side and get 0 on the other side. Now remember, I had square roots on both sides, so I'm going to throw them away. The 53 is also going to go over to the other side. So I have x squared minus 2x plus 1 plus 49 minus the 53 that came over to this side. That gives me x squared minus 2x minus 3. I factorize that and I get x is equal to x is equal to 3 or x is equal to negative 1. Now I go look back at my sketch and they said that this point is in the second quadrant. Now I marked the quadrants, quadrant 1, 2, 3 and 4. That's how you count the quadrants in the Cartesian plane. So the second quadrant is this quarter right here is called the second quadrant. D is in the second quadrant. Now I need to check which of these answers will be in the second quadrant. In the second quadrant, the x values will be negative. So that means only x is equal to negative 1 is going to work here. X is equal to 3 is not applicable. So the coordinates for D will be negative 1, 5. Then number E. Given that PQ is equal to PR, so that means I have the point P, and then I have a Q and a R that is equal in distance from point P. Okay, so what I do is I put the formulas for the distance between QP and PR, I put them equal because they give it to me that it is given to me that PQ and PR are equal. Now I go substitute all the values in, and then I get 2 minus negative 3 squared plus 7 minus 2 squared, and on the other side 10 minus negative 3 squared plus y minus 2 squared. I need to find y. Okay, now I'm going to say on the left hand side I'll get 25 plus 25, and on the right hand side I have 10 minus negative 3, which is 7 squared, gives me 49. And then I do the FOIL rule. Y minus 2 times y minus 2 gives me y squared minus 4y plus 4. Because I have a quadratic equation, I'm going to take everything over to the one side so that I have 0 on the other side. So I have y squared minus 4y plus 3. Factorize that and I get y minus 3y minus 1. So y is equal to 3 or y is equal to 1. And that's my answer. That's it for today. If you have any questions, email your teacher.